Be careful. Yes, this question has a trap, and there is something unusual about it. Welcome back to my channel. So in this particular question, we are told that a right angle triangle has an area of 210 centimeters square. Yeah, calm down. As easy as it looks, it's not that easy. Now, how many different triangles are possible? That means we need different triangles that will still give us the same area as this one, right? Meaning that we are meant to find different values of A, B, C that still satisfies this particular area in different triangles. Are you ready? Let's go. So first thing we need to do is, first of all, I need to clean this because I will be needing that space. Yes. I need you to grab your popcorn and sit down and watch this video because it's going to be filled with a lot of things to learn. Okay, now looking at what we have here, the first thing we need to do is this. First of all, area of a triangle is half base times height, right? So we have area half base times height, okay, which can be written as base times height divided by 2. So we have our area as 210 centimeters squared. So we write 210 is equal to this. Okay, so we can write this as 210 divided by 1. I normally like to cross multiply. It is faster for me. Okay, so but you can actually multiply both sides by 2. Okay, this and this we go, and we have that BH, which is the base times the height, will give us what? 210. Now in this, we give us 420 because we are multiplying by 2, so we give us 420. So we have 420. Now I want you to note something. Our base is B, our height is A, so I can write this as AB, right? Now AB is 420. This is very important. Do you know why? Because it's already telling us that the sides are what? Whole numbers. Okay, the sides are whole numbers, and we are told that the sides are whole numbers. So I'm sorry, I think I omitted that. Now what we are going to do from here is this. First, we need to find all factor pairs of 420. That is where we are going to start from. All factor pairs of 420. I had to redraw this because I need this space. Okay, so like I said, we need to get all factor pairs of 420. Now what are factor pairs of 420? They are 1 times 420, 2 multiplied by 210, 3 multiplied by 140, 4 multiplied by 105, 5 multiplied by 84. Let me stand like this. 6 multiplied by 70, 7 multiplied by 60, 10 multiplied by 42, 12 multiplied by 35, 14 multiplied by 30, 15 multiplied by 28, and 20 multiplied by 21. Yeah, so these are the factor pairs of 420, but that doesn't mean that all this are the sides of different triangles that will give us 210 when we solve for their areas. No. Now how do we now verify which of these will actually give us an area of 210 centimeters squared as a right triangle? Now it is very important that we note that this is a right triangle. It's not an isosceles triangle, it's not a scalene triangle, it is a right triangle, meaning that any of them we are going to make use of must concur with the Pythagoras theorem. All right, it must concur. Anyone we are going to choose must concur with the Pythagoras theorem, and there is a lot of possibility that we are not going to get what? Only one answer to this particular question. Are you ready? Now let's go. First of all, remember the Pythagorean theorem. It states that in a right angle triangle like the one we have here, the sum of the square of the two sides is equal to what? The square of the hypotenuse. So it means that a squared plus b squared is supposed to give us c squared. So that is very important. Now, I'm going to be making use of calculator because I don't want to waste our time. If this is the first time you're coming across this channel, please click the subscription button. It's for free. Just click it so that you don't miss my videos. If you don't subscribe, there is possibility that this might be the last time you'll be seeing my face. So if you want to keep seeing this face and keep gaining values, hit the subscription button, turn your notification bell so that you don't miss our videos. All right, thank you very much. Now let's continue. Yeah, tune in all the time. There must be something new for you to watch. By the grace of God, because it's not easy to be consistent, I must admit that. So looking at what we have these sets of what factor pairs. Now let's go straight to the point. So when we are looking at 1 times 420, that means we are taking A to be 1 and B to be 420, right? So we have 1 squared plus 420 squared. Okay, now let us solve that. 1 squared is 1. 420 squared will give us that will give us 176,400. So if we add these two, we are going to have 176,401. Now 176,401 is not a perfect square. Yes, and once it's not a perfect square, that means, but before that, we can actually find the square of these three-digit numbers without the use of a calculator. Yes, and I'm going to show you that just for this one so that we don't waste a lot of time on this video. Now let's go ahead. If you have a 3-digit number to square, do it this way. 420 squared, 0 squared is 0. Always write your answer as a 2-digit number, so I'm going to write 0 0. 2 squared is 4, so I'm going to write 0 4. 4 squared is 16, is already a 2-digit number. Now we continue. 4 times 2 is 8. I will double that 8 to get 16, and I will leave the first digit and I will write it here. It's a trick. Now 2 times 0 is 0. If you double that, you are going to get 0. 4 times 0 is 0. If you double that, you're going to get 0. I'm going to leave the link. I'm going to drop the video, okay, where I explain this in detail. I have it already in this channel, but I'll be dropping it as a card before the end of this video. So if you want to see this as a topic, as a particular video where I analyzed it from 2-digit number to 3-digit number, okay, that means you need to watch towards the end of this video. I will be attaching it as a card towards the end, so you go there and watch it and learn how to do this in a jiffy. So because this ends in 0, I don't need to continue stressing myself. At this point, I've gotten my answer. I'll just add what I have. Bring down 0, bring down 0, bring down 4, bring down 6, bring down 7, bring down 1. You can see this is it. Okay, that is 176,400, 420 squared. Now, like I said, I'll be dropping the link, the card, the video as a card towards the end of this video. So let's continue. Now 420 squared is what? 176,400, and when we add them together, we get this. Now this is not a perfect square. I also have a video that will tell you, by looking at a particular number, whether that number is a perfect square or not. I will also attach it as a card towards the end of this video. I can attach it anywhere towards the end of the video, so watch to see how to do that. But by me looking at this, this is not a perfect square, so we are not going to use this. We continue our searching. Now let us go to the second one. 2 times 210. Now 2 squared plus 210 squared. Now 2 squared is 4. 210 squared will give us 4410. So this is 4 plus 44100. If we add this, we are going to have 44104. And this is also not a perfect square. Yes, it is not. Let's check another one. So at this point, if I get to this point, I'll start fast forwarding this particular video. Okay, because I don't want it to be too long. So we check 3 squared and 140 squared. Now let's see, 3 squared is 9. We just need to check 140 squared, and that will give us 9 plus 19,600. Now if we add that, we are going to have 19,609. Okay, and this is not a perfect square. Let's go to 4 squared plus this. We are here. Now let's check. We have 16 plus 105 squared. We have 11,025. If we add this together, we have 11,041. This is not a perfect square as well. Have you subscribed to the channel? If you have not, then you need to do that. You need to do that. Okay. So let's continue. Now we have 5 squared and 84 squared. I just checked and I noticed that the camera is already reading longer than I want it to do. So what I'm going to do is you keep checking it this way. Okay, if you keep doing that, you will notice that when you get to 12 times 35, we have 12 squared plus 35 squared. Okay, 12 squared will give us 144. Now 35 squared, this ends in 5. We can easily get the square, right? 5 squared is 25. Now after 3 we have 4. 3 times 4 is 12. So this will be definitely the square. It's going to be, it's already in the video I explained to you. Now what do? When we add this together, 144 plus 1225, we are going to have 1,369. Now this is a perfect square because 37 squared will give you this. Okay, 37 squared will give you this, and that means that we have gotten the first triangle. That means our triangle will have this sides 12, 35, and then square root of 1369, which is 37. I just realized that at this point my video cuts and I've been talking to myself. That's not easy. That is why I'm shooting this again and I feel I'm already tired, but I have to complete this video. So we have gotten this. Now let's check this as well. Like I said, I already know the ones that will be giving us our answers. So let us check this again and we are going to get the next triangle. Okay, so if we use 20 and 21, we are going to have 20 squared plus 21 squared, right? Now 20 squared is 400, 21 squared is 441, right? Now if we add them, we are going to have 841. Now we know that 841 is a square root, and square root of 841 is 29. Therefore the second triangle is going to be of the sides 20, 21 and 29. Now let us verify just one. I told you the video is already long, so let's verify one to be sure that our answers are correct. So if this is our right angle, okay, we have 20, 21 and 29. Now let's see if the area is also 210 centimeters squared. So we have, like we did here, 20 squared. Sorry, area is half base times height, so half times the base is 21, the height is 20. So it's going to be half times 21 times 2 into 20 will give us 10. So what we have here is 21 times 10. I'm already tired. 21 times 10 will give us 210, right? So you can see that yes, the area is also 210. So that is it. Thank you so much for watching and see you in my next video. Bye.